Theme type equals WeChat color equals WeChat blue title equals theme title -1 theme. What is life? Schrödinger's revolutionary insights explained ##. Introduction. The physicist who redefined biology. Did you know a quantum physicist accidentally started the molecular biology revolution? While Erwin Schrödinger is forever immortalized by his Schrödinger's cat thought experiment, mind-bending paradox about quantum superposition, few realize this Nobel Prize-winning physicist quietly planted the seeds for DNA's discovery with a series of lectures about chromosomes in 1943. This Austrian genius who laid the foundations of quantum mechanics with his 1926 Schrödinger equation and won the 1933 Nobel Prize in Physics, decided to turn his gaze from subatomic particles to something even more mysterious: life itself. Imagine a room of 400 people packed into Trinity College Dublin in 1943. The world was engulfed in World War II. And here was a physicist asterisk, a quantum physicist asterisk, talking about chromosomes. At the time, biology and physics might as well have been different planets. Biologists studied cells under microscopes, while physicists puzzled over atoms. But Schrödinger saw a connection no one else did. How does life defy the second law of thermodynamics? He asked. What makes chromosomes store genetic information for decades? The audience had no idea they were witnessing the birth of a revolution. Those lectures became What is life? Published in 1944, a slim, 60,000-word book that would become one of the 20th century's greatest science classics. Written in Schrödinger's witty, accessible style, it used thermodynamics and quantum mechanics to tackle biology's biggest questions. How do living things maintain order? What physical principles govern heredity? As philosopher Karl Popper hailed, it was a beautiful and important book that didn't just explain life, it redefined how we study it. Schrödinger's gamble was radical. As a physicist venturing into biology, he risked criticism for stepping outside his field. But he argued that science had become too fragmented. Understanding life required bridging disciplines. And bridge he did. By suggesting chromosomes might be aperiodic crystals storing information in their molecular structure, he essentially predicted the existence of the genetic code decades before Watson and Crick discovered DNA's double helix. Highlight greater than the ripple effect ***. Schrödinger's work wasn't just theoretical. It became a magnet for brilliant minds, drawing physicists, chemists, and mathematicians into biology. Researchers like James Watson later admitted what is life? Was their roadmap for exploring DNA. By the 1950s, the molecular revolution was underway, all sparked by a physicist who dared to ask, what is life? Highlight greater than today. We're breaking down his 3 mind-blowing ideas that changed science forever. How life fights entropy, the physical basis of heredity, and why his aperiodic crystal hypothesis became the key to unlocking DNA. Get ready to see life through Schrödinger's eyes. You will never look at biology the same way again. Core insights. Schrödinger's game-changing ideas. Aperiodic solids and the genetic code. If regular crystals are like repeating wallpaper patterns, where every molecule mechanically copies the previous one's dance steps, then aperiodic solids are unique molecular novels. Each letter is an isomeric small molecule unit, telling the story of life through precise arrangement. 1. https://blog.csdn.net/galaxy_robot/articles/details/108-016937. This analogy proposed by Schrödinger in his 1944 lectures revealed the physical essence of genetic material. The secret of life lies not in repetitive crystalline structures, but in aperiodically arranged molecular codes. Traditional crystals have atomic arrangements like ytterbium formations, orderly but monotonous, incapable of carrying complex information. Aperiodic solids, however, consist of countless isomeric units, these small molecules, through structural specificity like movable type printing blocks, can store vast information with minimal matter. Schrödinger estimated that the core of this molecular codebook, the gene, measures only about 300 angstroms, 30 nanometers at its largest scale. containing conservatively fewer than 1,000 atoms, yet compressing all instructions controlling biological development, traits, and reproduction. 1. https://blog.csdn./galaxy_robot/article/details/108016937. This ability to store macroscopic information in microscopic space is precisely what distinguishes life from non-life. Highlight greater than asterisk asterisk Schrödinger's prescience asterisk asterisk shines here. When he called chromosomes hereditary code scripts, Mendel's theory of genetic factors had only recently been rediscovered. While Morgan's chromosomal studies confirmed genes as hereditary carriers, no one had considered their molecular form. 2. https://say ighukang.com/ygu all my ngzhu/17068/ His radical proposal that genetic information is stored in molecular structure injected physics crystal concepts into biology, laying the groundwork for DNA's later discovery. 3. https://www.mentoring-club.com/our-library/erwin-sch-and-matter-and-sketches Highlight. This insight transcended theoretical significance. Schrödinger's aperiodic crystal hypothesis not only defined genes as organic molecular codes, but revolutionized genetic research paradigms. Scientists began searching for genetic material at the molecular structural level rather than remaining limited to cellular observations. For https://www.what-is-review/closing parenthesis. Today, personalized medicine predicting disease risks through genetic sequencing and biotechnology editing DNA to improve crops all trace back to the molecular information seeds planted in this pamphlet. Yet in 1944, this idea was so radical it met with collective silence from biologists. What right did a physicist have to define life substances? It wasn't until 1953, when Watson and Crick discovered DNA's double helix structure, that people realized Schrödinger's aperiodic crystal was precisely this 缠绕, twisted, molecular chain. Those isomeric units were the four bases A, T, C, G. That molecular novel was the human genome written with 3 billion base pairs. This 9-year cross-disciplinary dialogue proved that true scientific revolutions often begin with breaking disciplinary boundaries. Negative entropy. Life's thermodynamic trick. Drop milk in coffee, it mixes, right? That's entropy in action. The natural drift from order to disorder, like how your desk gradually gets cluttered, no matter how you organize it. Entropy is simply a measure of this chaos. The second law of thermodynamics says isolated systems, like that coffee cup, always tip toward maximum disorder. But here's the puzzle. Your cells are the opposite of that mixed coffee. They're tiny factories with precisely folded proteins, neatly packed DNA, and perfectly timed chemical reactions. How does life defy this universal chaos? Scientists argued for decades. How can living things stay orderly when the universe is busy falling apart? Schrödinger's answer? They don't defy the rules, they just play them better. His revolutionary idea? Life feeds on negative entropy. Think of negative entropy as borrowed order. Instead of creating order from nothing, life extracts it from the environment to offset its own chaos. 5. https://book.doban.com/subject/37004609/ closing parenthesis. 6. https://www.uk/research/project/cogaf/mic/s///// Here's how the trick works. Your body is an open system, not isolated like that coffee cup. 5. https://www.uyun.cn/index.php. ID equals 16153370059 and R equals space %person% blog %view. When you eat a sandwich, a highly ordered arrangement of molecules, your cells break it down and repurpose the building blocks into new proteins, DNA, and tissues *, increasing order locally *. But to do this, you must export even more disorder. You breathe out CO, disorder, and radiate heat as waste. https://blog.csdn.net/galaxy_robot/article/details/108oyog37. It's like cleaning your room by shoving all the trash into the hallway. Your space stays tidy, but the building's total chaos increases. 7. https://m.baike.com/wiki 17%9 是什么？ E4 BB8 哦 E4 B88/19377 OZ9 Bake source 等于豆包 Highlight greater than **** the thermodynamic magic of being alive ****. Every cell acts like a tiny Maxwell's demon, a hypothetical gatekeeper sorting order from disorder. 8. https://cloud.tencent.com.cn/developer/news/2183058 When you feel energized, that's negative entropy at work. Your body is borrowing order from the world, in the form of food, sunlight, or oxygen, to delay the inevitable march toward equilibrium. As Schrödinger put it bluntly, death is when the organism can no longer extract negative entropy to counteract its internal entropy increase. 9. https per meter bake com wiki %e 7% 94% 91% e 5% 91% bd e 6% 98% af bb 80% d4% b9% 8819,377,029. Bake _source equals Dobao closing parenthesis. Highlight. So the next time you take a breath or eat a meal, remember, you're not just fueling your body, you're performing one of the universe's greatest magic tricks. Life isn't a rebellion against entropy. It's a masterclass in strategic chaos management ## quantum mechanics and mutations. Imagine genes as superheroes in stable costumes until a quantum power-up suddenly transforms their look. That's the wild idea Erwin Schrödinger proposed in *. What is life? *. Mutations aren't random mistakes, but ** quantum jumps ** that rewrite life's code. Let's break down how the weird rules of the quantum world shape the diversity of life. ### The quantum basics. Why genes stay stable, mostly. Classical physics couldn't explain why genes stay intact for generations. If they were just tiny machines, random molecular jiggling would have long ago scrambled our DNA. Schrödinger argued genes follow ** quantum rules ***. They exist in discrete energy states, like a ball sitting safely in a valley. The ball needs a precise energy push to roll over the hill, a quantum jump, and without that push, the gene stays stable. This stability comes from *** covalent bonds ** quantum glue, called Heitler-London forces, which hold atomic sequences together, but aren't unbreakable. 10. https://blog.csds2s uds 8 x edif 0v/article/details/1356 14006 11 http://m.com/94064 52. This quantum protection is why traits like eye color or flower shape pass reliably from parent to child. But here's the twist. Quantum mechanics also leaves the door ajar for change. Just as electrons jump between energy levels in atoms, genes can ** suddenly switch configurations ***, and that's where mutations are born. https per meter bake comwiki %e 7% 94% 90% e 5% 91% bd e 6% 98% af bb 80% e 4% b 9% 88 19,377,029 bake underscore source equals dobao closing parenthesis. # mutations. Quantum leaps in action. Think of a gene as a molecular superhero with a fixed costume structure. A quantum jump is like a sudden costume change, same hero, new abilities. Schrödinger described mutations as *** jump-like changes ***, where a gene 吸收能量 absorbs energy and flips from one isomer molecular arrangement to another. This isn't a gradual tweak. It's an all-or-nothing shift, like flipping a light switch. 10. https://blog.csdn.net/cf2su-8x8f0v/article/details/135614006 12 2 gug doban/subject/37004609/ closing parenthesis. Why do mutations happen constantly? Because quantum jumps need *** specific energy inputs ***. It's like needing exactly 10 coins to use a vending machine. Too few, nothing happens. Just enough. An *** bam***. A new mutation. This high energy barrier is why most genes stay unchanged for eons. 10. https://blog.csdn.net/cf2su-8x8f0v/article/details/135614006. Enter X-rays. These energetic photons act like quantum coin dispensers. In the 1920s, scientists noticed X-rays caused weird traits in fruit flies, extra wings, misshapen eyes. Schrödinger connected the dots. X-rays supply the precise energy needed for quantum jumps. Experiments later confirmed two key rules. ***, more X-ray dose equals more mutations ***. Each photon is a potential jump trigger, and *** wavelength doesn't matter ***, only energy counts, exactly what quantum theory predicts. 11. http://m.books.china.com/9406452. 12 @https://subject/370046009/ closing parenthesis. Highlight greater than ***, mutations as evolution superpower ***. Far from being errors, these quantum jumps are how life adapts. A single mutation might let a plant resist drought, or a bacteria survive antibiotics abilities that get passed down, thanks to the same quantum stability that kept the original gene intact. Schrödinger merged Mendel's P experiments, macroscopic inheritance, with quantum physics, microscopic jumps, to show every evolutionary leap starts with a quantum leap *8. https://cloud.tencent.com.cn/developer/news/2183058. 12 calvo/book.doban.com/subject/370046009/ closing parenthesis. Highlight ### when genius was called crazy. The quantum revolution in biology in the 1940s, geneticists laughed at Schrödinger. Genes were thought to be too big, too alive for quantum tricks. How could tiny atomic rules govern something as complex as inheritance? But by the 1950s, experiments vindicated him. Scientists measured mutation rates in fruit flies exposed to X-rays and found they matched quantum predictions perfectly. Mutations increased linearly with radiation dose, just like how atomic decays follow quantum probabilities. 1. https://blog.csdn.net/galaxy_robot/article/details/108 016937. 11 http://m.bookschina.com/94064522.htm. Then came DNA's double helix discovery, which revealed genes are indeed tiny molecular machines, exactly the aperiodic solids Schrödinger imagined, where quantum effects could tweak atomic sequences. 9. https per meter bake com wiki percent E7% 94% 90% E5% 91% BD% 98% AF% E4% BB% 80% E4% B9% 88 19,377,029. The bake underscore source equals Dobau closing parenthesis. Today we know quantum mechanics isn't just for stars and atoms, it's the hidden hand behind the diversity of life. Schrödinger's crazy idea? It turned out to be the missing link between physics and biology, proving once again, the smallest rules shape the biggest stories. Scientific legacy. How a physics book changed biology. 3 Nobel Prize winners walked into a lab. And they all had the same book in their pocket. Asterisk, what is life? Asterisk, this unassuming 1944 physics tome didn't just explain science, it redirected the course of scientific history by luring some of the 20th century's brightest minds across disciplinary boundaries. Take Maurice Wilkins, who abandoned atomic bomb research after reading Schrödinger's work. The physicist traded nuclear fission for X-ray crystallography, later becoming pivotal in capturing the iconic DNA images that revealed life's molecular structure. https://cloud.tencent.com.cn/developer/news/2183058 closing parenthesis. Then there was Francis Crick, a physicist whose pocket copy of Asterisk, What is Life? Asterisk became his career compass. He swapped quantum mechanics for genetics, famously stating the book made him see biology as the next big frontier. 13. https://lib2.bu.cn/bookinfo_01h13326332.ht. But perhaps the most dramatic pivot came from James Watson. At 22, he was a dedicated ornithologist until Schrödinger's words hit him like a revelation. I need to find that code script, he reportedly exclaimed, ditching birdwatching for the hunt to decode life's molecular language. 8. https://cloud.tencent.com.cn/developer/news/2183058. https://www.wuhanedu.yan.cn/index.php. ID equals 1,615,337,059, and R equals space %2FPERSON%2FB, log W AP %2FView. Highlight. Imagine a book so powerful, it redirected the careers of the scientists who'd crack life's biggest mystery. SC Schrödinger's stroke of genius? He proposed genetic information lives in an aperiodic crystal, a molecule with irregular atomic patterns that could encode hereditary instructions. 15. https://glasp.co/books/book/what is life with mind and matter and autobiographical sketches. 9 years later, Watson and Crick's DNA double helix model proved him right, with its twisting strands acting as nature's code script. 8. https://cloud.tencent.com.cn/developer/news/2183058. Highlight. This wasn't just a theory, it was a scientific baton passed from physics to biology. Highlight. The ripple effect. Schrödinger's quasi magic turned biology into a quantitative science, inspiring the molecular revolution of the 1950s and beyond. 16. https://www.com/1099-4300/22/815. Today, every genetics lab studying CRISPR or personalized medicine traces its roots back to that slim physics book. As Watson once put it, Schrödinger didn't just ask, what is life? He gave us the map to find the answer. Talk about a game-changing page-turner. Conclusion. Why Schrödinger still matters today. Schrödinger didn't just explain life, he taught us how to think. Across disciplinary boundaries. Against conventional wisdom, with unquenchable curiosity. Concepts like life feeds on negative entropy and aperiodic crystals proposed in What is Life? Not only built the theoretical framework for molecular biology, but continue inspiring breakthroughs in quantum biology and synthetic biology today, from CRISPR gene editing to artificial cell replication. His insight that life is a trio of matter, energy, and information keeps gaining new interpretations. Highlight. Whether you're a physicist, biologist, or simply a lover of scientific adventure, this book reminds us the greatest breakthroughs often begin with that 勇敢的, courageous question, what if? Highlight. Greater than thanks for joining me today. Let's keep curiosity alive. Now it's your turn. What do you think is life's most mind-bending property? Is it negative entropy, the quantum code, or something Schrödinger missed? Drop a comment below. I read every single one. YouTube thumbnail design. As the visual calling card of a video, YouTube thumbnails directly determine click UM. Science education content especially needs to balance professionalism and appeal. High CTR, click-through rate, thumbnails for educational videos in 2025 must satisfy both technical specifications and cognitive psychology principles. Here's the design. Plan. For Schrödinger's Secrets of Life. Number # technical specifications. 2025. YouTube official standards. Highlight. Core parameters size 1280 720 pixels, 16 to 9 aspect ratio. For clarity across mobile, tablet, and desktop. File size 2 megabytes. Prefer JPG for complex gradients like DNA helices, or PNG for sharp text, mobile optimization. Minimum 40px text size. Critical elements in safe zone, avoiding 15% edge margins. Highlight # scientific narrative visual design **** 1. Central visual focus **** use split screen composition. Left side features **** Schrödinger's portrait ****. Smiling. Approachable expression. Right side shows **** DNA double helix ****. Vibrant blue-purple gradient with subtle glow for technological feel. This design aligns with psychological findings that thumbnails containing human faces generate 921,000 more views, while the DNA element 直观传递 intuitively conveys biological themes, preventing audience confusion. 17. https://ampifire.com/blog/best-youtube-thumbnail-guide-practices-2025-4-hi-ctr/closing parenthesis. ***2. Text information hierarchy *** main title Schrödinger's Secret to Life uses * bold yellow font with red outline ***, keeping character count under 12, following industry conclusions that short text thumbnails perform better. Omit subtitles to ensure readability on mobile screens. 17. https://ampifire.com/blog/best-youtube-thumbnail-guide-practices-2025-4-hi-ctr https://myra-camp.com/learn/youtube/how-design-thumb-nails. Highlight. 星星 text design mantra. 星星. Color. High contrast combinations. Yellow text with red outline achieves greater than 70%. Brightness difference on blue-purple background. Font, sans, serif. For example, impact or Arial to avoid readability issues with serif fonts, placement, center-bottom alignment, forming a visual triangle with split-screen imagery. highlight, asterisk asterisk 3, background narrative logic asterisk asterisk left background incorporates asterisk asterisk entropy diagrams asterisk asterisk, blurred gradient of mixing coffee cream, transitioning to asterisk asterisk green cellular structures asterisk asterisk mitochondria, cell nuclei, on the right. This visual metaphor embodies Schrödinger's core idea that life feeds on negative entropy. The design maintains educational content rigor while using color, contrast, cool background plus warm text to stand out in YouTube feeds. 19. https://thumbnail-test.com/guide/psychology-of-umbnail/closing parenthesis. # data-driven. Optimization strategy. Top educational channels demonstrate that asterisk asterisk science thumbnails must balance curiosity arousal with content authenticity. Asterisk asterisk avoid exaggerated expressions or irrelevant visual elements, for example, unrelated formulas, explosion effects, which may cause high CTR but low watch time. Algorithm penalties. 建议, recommend, A/B testing 2 versions. For example, Schrödinger facing front-side profile. Monitoring CTR changes over 14-day cycles with target range 5 to 8%, exceeding the 3 to 4% educational video average. 17. https://ampifire.com/blog/best-youtube-thumbnail-guide-for-high-CTR/closing parenthesis 20. https://learning-portal/youtube-thumbnail-sizes/ This fusion of scientific symbolism, emotional portraiture, and cognitive psychology will satisfy 2025 YouTube trends for professional visualization in educational content while 激发 stimulating audience exploration through the discovering secrets narrative hook, ultimately transforming from being seen to being clicked.